Greetings, podcast listeners. This is Matt. Haven't greeted you this way in a while, but did want to take one more opportunity to, first of all, thank those of you who've donated to help save the show. It has meant a tremendous amount to us and has helped to assure the future, at least for the time being, of Planetary Radio. And so once again, we are incredibly grateful. We do have another favor to ask, especially of you folks who are listening to this perhaps via iTunes or your favorite podcast aggregator. Pretty much all of them allow you to submit your rating of the podcast that you listen to, and even to write a review. Some folks out there have written glowing reviews of Planetary Radio that we see on iTunes, and we are very grateful for that because that means other people are going to find the radio show, give us a shot. If you have a moment, we do have this favor to ask. Please give us a rating, award us some stars, whatever you think is appropriate. And if you have an extra couple of minutes, write one of those reviews. They make it very easy at iTunes and pretty much all the other places that you may find our radio show each week. Thanks a lot for listening. Here's the show. The meaning of life, this week on Planetary Radio. Hi, everyone. Welcome to Public Radio's travel show that takes you to the final frontier. I'm Matt Kaplan. Sorry to disappoint, but the life we're talking about is the living interplanetary flight experiment. And the guy managing this experiment is our own Bruce Betts of the Planetary Society. Bruce will tell us how an international team plans to send living organisms to Mars's moon Phobos and return them to Earth. Good thing they're not going farther into our solar system. Bill Nye, the science and planetary guy, will talk about a scarce resource that might make future trips to Saturn and beyond impossible. And speaking of beyond, Emily Lakdawalla will answer your question about why our mission to Pluto will sail on by that distant orb instead of going into orbit. Then we'll welcome Bruce back for another edition of What's Up. A busy show, but after all, it's a busy universe. One way to keep track of it is through Emily's blog at planetary.org. That's where she has some of the most exciting images snapped by the Lunar Reconnaissance Orbiter. You'll also find some of Emily's favorite tweets. That's tweets as in Twitter messages. Oh, and by the time you hear this, Space Shuttle Discovery may have set out for the International Space Station. The goodies it will deliver include a treadmill named after Stephen Colbert of the Colbert Report. Remember, he's only kidding. But Bill Nye is serious about plutonium. I'll be right back with Bruce.
Hey, Bill Nye, the planetary guy here, Vice President of the Planetary Society. In the news for me this week is the cutting of funding for NASA's plutonium program. Now, plutonium is nominally fantastically dangerous stuff, but it's quite useful when used in spacecraft. About 15 years ago, I had lunch with Glenn Seaborg. Unlike many of us, Glenn Seaborg had a Nobel Prize for inventing or creating the very first plutonium. He took uranium, which has 92 protons and the rest neutrons, and converted it to plutonium, which has 94 protons. And you get this material that has the subatomic particles smashing into each other, and it gets fantastically hot. And you surround it with thermocouples. These are fused pieces of metal that produce electricity when they get hot. And you can power a spacecraft. A spacecraft so far from the sun that there's barely enough photons to turn on its solar cells. So we use these radioisotope thermoelectric generators, RTGs, in all kinds of spacecraft. By cutting the funding for the creation of plutonium, which I admit is fantastically dangerous stuff, we limit our ability to explore the nearby solar system. And when I say nearby, I understand we're talking about billions of kilometers away. So actually, by reducing the funding for this program, we're lowering the quality of life for people all over the Earth because we won't be able to explore our solar system and other worlds and stars. Not only that, my friends, there are asteroids out there. One of them has got to have our name on it. And if we're going to explore that part of space and look for those asteroids, which could turn us into the same kind of extinct life forms as the ancient dinosaurs, we need to have this technology, this plutonium and radioactive isotope production in order to have a quality of life for everybody in the world. It's a strange thing. So next time you go to vote or write a letter or support the Planetary Society, keep that plutonium in mind. I gotta fly, Bill Nye the Planetary Guy.
The Planetary Society's life experiment is still on track for a piggyback ride to one of the moons of Mars. Challenges remain and a delay is possible, but as we get this week's show out to you, the Living Interplanetary Flight Experiment is set to launch on the Russion Phobos Grunt mission in October. You know Bruce Betts is our solar system tour guide, provider of space trivia contest questions, and singer of random space facts. But his work as the Society's Director of Projects includes the shepherding of this unique project. Dr. Betts, formerly of the Planetary Science Institute and NASA, got his Ph.D. from Caltech. He was still at that school when he got involved with a much earlier mission to Phobos, as you'll hear in a few minutes. We met recently, as we so often do, at Society headquarters. So, what is the meaning of life?
The meaning of life is, of course, living interplanetary flight experiment.
Well, I thought you were going to say 42, but I like that better. Tell us about this experiment.
42 is not a prime. Clearly, it's not the answer. Hey, this experiment is trying to fly microorganisms to Mars' Moon Phobos and back. The real purpose is testing whether life can survive in deep interplanetary space, because no one has ever flown life, not just the experiment, but the critters, to interplanetary space for any extended period of time and brought it back and seen if it could survive. They've done it in low Earth orbit. It's done for very few days on Apollo 16 and 17. Not in deep space, where you have a different environment that's not protected by the Earth's magnetic field. You get more high-energy charged particles and other nastiness. And basically the whole thing is a simulation of a meteoroid traveling through space with organisms inside it to test a part of the transpermia theory, whether you can transport life between the planets, for example, ejecting them off, say, Mars in an impact, if life were there, and having the rocks travel and end up on Earth.
Since we know that there are Mars meteorites, or rocks that originated on Mars, the thinking is that, well, who knows? If there was life on Mars at one point, maybe there still is, it could have just hidden out in one of these guys and made it here to Third Rock.
Exactly. And theoretical studies, and besides actually having Mars meteorites, theoretical studies show that you can get a few of these over the long history of the solar system actually being delivered on very short time frames, like the duration of this mission, 3 years, although most would take longer.
How did this come about? What's the origin of LIFE, life?
The origin of life. You're going to have fun with this all through this interview, aren't you?
I am. I'll just call you Charlie. Charles. Darwin.
Oh, that guy. Didn't he have a dog, a beagle or something?
Yeah. I think he was very fond of it.
This actually grew out of a smaller experiment that the Planetary Society was involved with when our science principal investigator, David Warmflash, came to us many years ago and had an opportunity to fly just bacteria films, kind of stuff you kind of want to scrape off the wall of the shower. No, not really. But bacterial films, and they flew on what was unfortunately Columbia's last flight. So it was a space shuttle experiment, low Earth orbit, very brief time frame. I recovered the experiment, but was not able to do any analysis. But that was kind of a start into it. Then Lou Friedman, Executive Director of Planetary Society, kind of saw that wouldn't it be great if we could do this in deep space? And it turns out, in talking to David Warmflash and others like George Fox at University of Houston, that's the real unique contribution here, is that people have done a lot of experiments on life. They found it to be very hardy in low Earth orbit, but they haven't tested it beyond that. So we're going to take the science another step farther, and it turns out the Phobos Grunt mission, which we're flying on, Russion Phobos Grunt meaning soil, their primary purpose is to go land on Mars' moon Phobos, collect samples, return them to Earth. Well, they are the only deep space sample return that's going right now, and have been for a few